Somebody.
What is Pythagorean? Pythagorean.
It's not Pythagorean.
It's hard to even say, isn't it? Pythagorean theorem. Okay, so here we go. We'll do it. We'll take it. We'll take what Kaya said. First off, if we can't say it, at least be able to say what it is.
I'm going to say pi theorem.
Pi theorem, Pythagorean theorem, Pythagorean theorem.
How do you say it?
Pythagorean theorem.
Pythagorean theorem.
The dude's name was Pythagoras, if that's easier to say.
I can say that, but I can't say
Pythagoras'
shisha.
theorem. That Pythagoras guy came up with a theorem. But if you can't, most important is, what is it? What is it? What is it? What is it?
Yeah, but I can't say it. I can't, if I say it real slow.
Focus this way. Focus. This is going to go quick, but I need your focus because what I have noticed of the previous week or so is those of you who get the Pythagorean theorem, when you come to these, then all of a sudden your hands are up and you need help. But this isn't easy, so let's cover it really quick on 3 examples, and then you'll have it. And then you won't have to ask questions because you'll have it. Big thing is there's 3 types of problems, and I'm showing you one of each. And now if there's a 4th type of problem, I haven't seen it myself, so maybe that's when you can raise your hand for help. But I've only seen 3 types. So we're going to cover each one. Each time you're asked to prove if a triangle is right or not. You're given 3 sides. You're not even given a picture. You're just given 3 side lanes. And you're supposed to go a squared, b squared, c squared. So let's look at this first problem. And this is the one that just makes people raise their hand and go, what do I do? How many of the triples could be of a right triangle? So this is a triple 3. These are 3 sides of a triangle, and the question is, could this be a right triangle?
Yes.
So what we got to do? Yeah, this one's going to be a yes. But here's how we're going to do it. We've got 3, 4, 5. What are the smallest 2 numbers there? 3 and 4. That's your A and B, 3 and 4. So what you're going to do is go 3 squared plus 4 squared. 3 squared plus 4 squared. That's 25. And then you have to ask yourself, what's 5 squared? It is also 25. So if your a squared plus your c squared, a squared plus your b squared equals your c squared, what do we say? Is it a right triangle?
Yes.
Yeah. So you got 1. You got to test each one of them. Now you have 1, but there's 4 possible ones. So the next one, you got 24, 71, and 74. So in your calculator, you go 24 squared plus 71 squared. Hit enter. 5617. Then you want to see, does that equal the same as 74 squared? And no. So you got 5617, and you got 5476. So that would be a no on triangle 2. So this is a no on this one. All right, triangle 3. What's my smaller 2 sides? 27, 36. So 27 squared plus 36 squared. 25. And I want to see
45.
if 45 squared is the same. Yeah. All right, so then that's a right triangle. And when I come to the last one, this one's a little weird because your smallest side is 5 and 12, and your biggest side is also 12 because it's a tie. But you'll still just go 5 squared plus 12 squared, which is 169 and 144.
I feel like this is going to take a long time.
That's not.
There's only 3 of these. So how many triangles do you have that are right?
2.
2. Sometimes you'll have 4. You'll at least always have 1 though.
Yeah.
You got this 103, 104, and this one is 105. This is kind of the end of the Pythagorean theorem stuff until you get into next week where we start learning SOHCAHTOA. SOHCAHTOA.
Yeah, I like the sound of that.
Well, it's very, very, very important. Like I said, it all goes to that 40% of your end of the year test. Okay, which of the triangles could be a right triangle? Now, here's what I want you to remember. You always take the smallest 2 as your A and B. Now, normally, these are the smallest 2. So we could go A, B, C. A, B, C. But look at this one. Where's the biggest one? 13. So what's your A and B?
5 and 12.
5 and 12. So when we get there, let's go 5, 12. First question is we got to go 14 squared plus 12 squared, hit enter. And we want to see if that's the same as what squared?
26.
26 squared. Doesn't look like it, so we'll cross that out. It's not going to be Q. Then I'm going to go 13 squared plus 14 squared. And I want to see if that's the same as 182 squared. It's probably not. That's probably a huge number. So no. Now when you get to S, this is where you have to go. Don't go 13 squared and 12 squared. You want to go 12 squared plus 5 squared, or 5 squared plus 12 squared. Hit enter. Check to see if that's the same as 13 squared. And it is. So the answer is S. The answer is S. I do want to show you one thing about T, because T confuses people. If we did 13 squared plus 12 squared and hit enter, you're going to see something weird. 13 squared plus 12 squared. You're going to see 313. But we're not trying to make it 313, we're trying to make it 313 squared. So you go 12 squared and 13 squared. Does that equal the same as 313 squared? No.
Whoa.
A lot of people will see that 313 and see that 313 and go, that's 1. That's not how it works. This squared plus this squared, enter. Does that equal 313 squared? No. So that's why it's not. And last one up. Test each, wait, I was already at that. That's the next one. Here is you're trying to find one that's not, keyword not, which means 3 of these things are right triangles, one of them is not. 3, 4, 5.
That's right.
That's back here.
It's the side button.
Is it? I thought.
Can you see who it is real quick?
It is 3900 is the last 4 digits. No name.
Yeah.
And now everybody on the
That
internet
is a
knows 3900 calling during class. Okay, 345 is one that you should see. 345 is always right. So we're looking for a non-right. 6, 8, 10. If I want to check, I'm going to go 6 squared plus 8 squared. Does that equal 10 squared? Yes. So that one's good. 12, 16, 20. So 12 squared
Should equal 4.
plus 16 squared. Does it equal 20 squared? Yes. So this last one better be a no. So 7 squared plus 8 squared. Does that equal the same as 10 squared?
No.
No. So that is the one that's not right. And that is it. You're given lots of triples, and you're just trying to see which of the triples are right triangles or which are not right triangles using a squared, b squared, and c squared.
Can I turn it on the timer?
Yeah, that's it. All right, so let's go ahead and get started.